Okay, let me go back here. So see, now I want to create one table. So employee, so details, the ID, a number. Okay, I'm trying to create unique constraint. Okay, same thing, name, varchar, varchar. Okay, so not null constraint. Okay, so create. Tell me if I want to create, what should be there? If I want to create any database object, what required?
A DB and schema.
Database and schema. So tell me in real time who will get this database and schema, which guy?
Admin.
Admin,
Administrator.
Snowflake admin field. Okay, we'll work on which one? Work on the development database. Okay, same thing. So create one schema. So create schema development database. So dot development schema. So this is fine. Daily, what type of call will be there? What type of call?
Stand-up call.
From call.
Scrum call
Scrum.
or stand-up call. Okay, who will
Daily.
participate? All the
Team
team
member.
members will be participate. Okay, discuss on the Jira stories. So Jira stories. Okay, so this is fine. Now what happened in the Jira stories? I want to create a table. Tell me how it's list of tables.
Two
List
tables.
of
Show
tables.
table.
Show tables. Okay, see show tables. Okay. Show tables. Show tables. Okay, see show tables. Okay, show tables. Okay, show tables. Okay. Now how to fetch the data?
Select star from
Select
Select star
star
from table name. Okay, see simple concept. We'll see one more time. So select star from table name. It's projecting all the columns and all the records. Now how to get the DDL? DDL. Select get
Get
DDL.
DDL.
DDL. Okay. So put table and the table name. Now see, this is important. See the DDL. Okay. Control and Control V, change the language. Now I want to populate the data. Tell me how to populate the data. By using what concept? By using DML, that is insert statement. So insert into, okay, so see, this is important concept. Insert into table values 1, Praveen. Okay, see the same thing. So create the table. Okay, insert the record. So two records I'm trying to populate. You see. So two Kumar. Okay, so see, this is same important concept. So okay, how many records are there in my table? Two records are there. Tell me now, point is that what now I want to take a backup of the table in SQL. Tell me how to take a backup in SQL. We should go for what concept? Go for
test.
C-test. Okay, see now what happened. Let me go back here. Now I want to take a backup. Now we're discussing what the concept is, how to take a backup of the table in Snowflake. How many ways I can able to take a backup and what are the advantages and disadvantages? So what happened? One is C-test concept. Okay, C-test nothing but what? What is C-test? So create table name as select the star from
table
old,
name.
old table. Okay, so this is the functional. So I'm meeting everyone 1 second. So C-test nothing but what? C create table name as select star from old table. Now see the same thing. Now what is the table name? I forgot my table name. How to get? Show tables. Shows tables starting with the ending with. We should go for what concept? And go for what concept? Starting with the ending with the. We should go for like concept. So E percentage T. Okay, so we are getting this data. Okay. Now how many records are there here? Two records are there. Okay, see, two records are there. Okay, so see the same thing. Now what happened? C-test. So create table. So table name C-test as select star from our old table. Now we are discussing how to take one is submit yourself. Okay, see, we're going for C-test concept. See, create this table. Now what happened? Tell me now how many records will be there in my table? Two records will be there. So select a star from the table. Now how to get the definition? See, select get DDL. DDL single quote table and the table name. So see, so this is see the definition. Okay, change the language. Altel Yes. Okay. See the same thing. See, in Notepad++, we can able to compare two worksheets. Tell me what's the difference between main table and the CTS table. What's the difference? Anyone? Difference is what? What is the difference?
Constraints are not
Okay,
copied.
see, so see in my main table, constraints are there, unique constraint, not null constraint. But what about here? No constraints are getting populated. See, point is that what with the help of CTES, we can get the definition plus data. And what about constraints? No constraints are getting populated. So this is one with the help of CTES, I can get definition, data plus constraint. Any other way I want to create a backup table apart from CTES, anything? Is there any other concept? Then the concept of like is there. See, like, okay, see syntax. So remember for everything you should prepare the syntaxes. Create table, table name, okay, like old table. So point is that what? So create table. So new table name like old table. So this is the syntax. Let me go back to the Snowflake. See the same thing. What is syntax? So create table. So table name. So this is our original table. Okay, see, I'm going for CTES like is the keyword. So see what exactly we are trying to do in one. So with the help of this table, I am trying to create a backup table. Now see data is there. Tell me, data is not there. What about definition? See the same thing. Copy the definition. Okay. Let me go back to the same functionality. Okay. Control V. Now what happened? Compare. Okay. See the same thing. Now tell me what's the difference between main table and this like table in difference? Tell me. Okay. No difference. So see point is that what? So with the help of CTES, with the help of like what I can create, I'm getting definition. Data is getting a no data. What about constraints? Constraints also getting populated. So with the help of CTES, like one more important concept is that it is clone. So now we need to discuss what exactly clone. Okay, see now. So with the help of CTES, like we can create a backup table. And one more concept is that what it is? That is clone concept. So clone. Okay, see. So syntax that what? So create table name, clone old table. Okay, so this is the syntax. Okay, so create table name, clone old table. Let me go back here and write the syntax. What is syntax? So create table. Okay, see table name. Okay, clone and clone the old table. So see, this is important. Okay, see. So see, table has been cloned. Now, how to check the data? Tell me, data is there? Tell me, data. See this data is getting populated. What about DDL? See the DDL. Go back here. So see, go here. Control V. Okay, try to compare one more time. Now tell me what's difference? Difference? No difference. No, both are same. So let me conclude. This is important to see. Let me go back here. Okay, see. So now I'm going for clone. What are rating? Clone rating definition plus data plus constraints are getting populated. So this is normal thing. But important thing is that what, see now I'm having EMP table. EMP table contains what? Two records. Okay, plus okay. Tell me when two records is there, what happened? Storage also will be there. Data storage will be there. Now here point is before you need to understand. So see two concepts. One is storage cost and computation cost. Okay, so before understand this zero copy clone, I should you need to understand storage cost as well as computation cost. Okay, so there are two types of cost. One is storage cost and computation cost. So before this, you need to understand the Snowflake architecture. Okay, so this is important. Tell me how many layers are there in Snowflake architecture and Vanessa?
3 layers.
So 3 layers are there. So this is important. Listen. Okay, I'll try to explain detail. The scene. So there are three layers are there. Okay, see, okay, what are the three layers? One is cloud service, computation layer, and storage layer. One more thing. So see, in Snowflake, there are three layers are there. Cloud service, computation layer, and storage layer. So see the same thing. So three layers are there. One is cloud service, query processing, or computation layer.
Storage layer.
Computation or storage layer. See, simple thing, storage layer. See the same thing. So see this image important. Okay. So cloud service, computation, and storage layer. So three layers are there. Now what happened now? I have logged into, suppose see, I have logged in into the Snowflake data warehouse. Tell me now what happened. So user ID and the password you should enter, okay, correctly. Now who will hold all these things? Tell me who will hold all these things. Tell me which guy? Snowflake, which guy?
Admin.
The cloud service layer. Okay, see, so see, I'll explain detail. 1 second, hold on. Whenever I give any user ID password, now what happened? The cloud service layer, this will perform the authentication and authorization. So whenever I log anything, what happened? Which layer? The cloud service layer will come into picture. The authentication and authorization. So whether it's a correct user or not, this will be done by which game? The cloud service layer. Okay, the authentication and authorization. Now see, important point. See what happened. So see, forget about all these things. I'll try to explain one more time. Okay, see the same thing. Okay. So see, mute yourself. I'm muting everyone. So see, now what happened now? See, now let me go back here. Okay, let me open one more session. Now I'm trying to create one table. So create table T1 ID number. Tell me if I want to create what happened. Tell me what required. I should require one database schema. And one schema required. See, I'm creating one database, one schema. See, I'm creating one table. So see, it's creating. Okay, see, like, let me create. Now see what happened. Table has been successfully created. Okay, so see the same thing. Let me one more time. Now see here. Let me make it to suspend. So here we should understand compute WH. So compute WH is nothing but it's a virtual warehouse. Okay, see, virtual warehouse. Okay, see, if I want to process anything, okay, we should require computation power. Don't get confused, simple thing only. Okay, if I want to perform anything, I should require computation power. So computation power given by which guy? That is computer. This is there in which way? It's layer in the compute service layer. In the compute service layer, it contains virtual machines. Okay, if I want to process anything, I should require compute the CPU, so RAM, all this thing will be provided by which guy? The compute service layer. See, one more time. I am trying to create one table. See, right now status of this warehouse is what? It's in suspend status. One more time. Right now the status is in suspend warehouse. Now let me create one table. What happened? See, still it's in which status? It's in suspend status. So point is that what? So DDLs, whenever I create any table, tell me which layer will come into picture out of these three layers. Anyone?
Cloud service.
Okay, see, this cloud service layer will come into picture. The table name and the column names will be stored by this metadata layer. One more time. So this is important. Listen, you see, the entire concept depends on this thing. So whenever I create any table, what happen? The cloud service layer will come into picture. This metadata layer will be there. It captures the table name, the column names, number of records. This all the information will be captured by whom? Which guy? The cloud service layer, metadata layer. This layer one more time. Whenever I create anything, what happened? This guy will come into picture. It will capture all the things. Now, who is holding my information? The table information. This metadata layer information. Now, what happened? Now, see. Now, I want to insert some data. Insert is what? It's a DML. Insert into T100 values 1. Now tell me now our data will be stored where in my system? Where exactly? In which layer?
Service layer.
Cloud
The
storage.
storage. Let's see what happened. Whenever I insert what happened, the data need to store in the storage layer in the form of micro partitions, small partitions. Now what happened if I want to insert what happened? I should require computation power. Computation power given by which guy? Which guy?
Compute service layer.
Compute that is virtual warehouse. See what happens in what status? It's in started status. One more see. Now I am trying to make it suspend. Now what happened? Now I am trying to insert one more time second record. Now what happened? Now our data will be stored in physically here. Now who are putting this data with the help of this virtual warehouse? This guy is putting the data into virtual warehouse. See what happens? Getting enabled. So point is that what whenever I'll explain one more time, whenever we perform any DML, okay, or any DRL, I should require computation power. Computation power by given by which guy? Which guy? The virtual warehouse. Virtual warehouse is situated in which layer? In the query processing or the computation layer. Got the point. See, if I want to perform any DML, DRL, I should require computation power. This is given by this compute service layer. It's like machines. Okay, it's a cluster of machines to perform CPU, RAM, storage will be assigned to the same function. So see one more time. Let me go back to the one more session. So this is important. One more time. I'm opening. Okay, so mute yourself. See, I'm opening one more session. Now what happened now? I'm trying to create. Okay, so let me make it to suspend. So create the table. So create table. So T689. Tell me this is a DDL statement. Does it require computation power or not? Just tell me. So no. Okay. So before that, first we should have database and schema. Tell me why we should require database, because I want to store this data. First we should have database and schema. Tell me who will come into picture? The cloud service layer will come into picture to capture what? To capture the table name. Okay, the column names and record which came the metadata layer will capture. Now what happened? Let me perform insert statement. Insert into T678 values. Okay, 1. Now tell me now what happened? Who will come in picture? Tell me which guy will come in picture. First, which layer will come? So first, the cloud service layer come into picture, whether the database object is there or not. So see what happened. Now what happened now? Which guy will come into picture? The cloud service layer. Now our data is stored physically. Now who will come into picture? The virtual warehouse guy will come into picture. See, let me insert one record. Now what happened? So see, it's getting enabled. Now the data is stored in physical layer in the form of micro partition. Again, this information is holding this metadata. If I try to insert one more record, what happened? Tell me, second record. So this information storing physically. Again, this information getting updated in a metadata layer. So this is the process. When I try to insert anything, what happened? This data need to be updated for tracking purpose. So you got the point. And also as of now, tell me. Okay, this is the functionality. So what happened? Whenever perform anything, what happened? There will be two types of cost. What cost? One is storage cost as well as computation cost. Storage cost for what? For micro partition. Computation for processing our queries. Okay, how many costs will be there? There are two types of cost. One is storage cost. Okay, for storing the micro partition information. One more thing is that what? That is compute cost. Compute cost mainly for running the queries. Okay, see queries. Now here point is that what? Come to our topic. So CTAS like and clone. So see important thing, this one differences. Okay. Okay, so this is my main table. So see, my main table contains what? Two records. Now what happened? We'll have what type of cost? Data storage cost plus computation cost. Okay. So see this functionality. Now when I go for CTES, now we'll have storage cost. Will be there or not? Anyone? Any idea? Storage cost will be there or not? Okay.
Yes.
How can I prove? So see, let me go back in. Okay, see, let me. So take this functionality one more time. See, so create table Okay, so one more table. So Prav table, ID, number. Okay, see the same thing. So insert into, so Prav table. Okay, so values 1, 2. Okay, so 3 records are there. So 3 records are there. Now what happens? See the data, select the star from. So Prav table, how many records are there? So 3 records are there. Now point is that what now I want to make sure like, so see CTES. What is CTES concept? So create table, table name as select star from old table. Now question is that what? This require computation power or not? That was the question. Tell me require or not? Require
Yes,
or not?
Required.
Okay, required.
Required.
So see, so how can you prove? So see the same thing. So see now, so here remember, here 3 dots will be there. Click on 3 dots, search for view query profile. Now see what happened. So see in the query details, see one more time. So if I execute anything, what happened? Snowflake generating query. See, click on 3 dots, view query profile. Now see query details. Okay, tell me this is what it's using warehouse. Whenever I using any warehouse, what happened? Tell me. Tell me it's require computation
Computation
cost.
cost.
Compute cost. Suppose let me go to query history. Go for create table. Tell me create table require computation cover or not? Tell me this table. Yes or no?
Yes.
No, no.
Yes.
So no details no need.
Not
So
required.
detail no need. But what happened? I am trying to insert the data with the help of CTES. Now it require computation power. So point is that what with the help of CTES we get compute cost also is there. Okay, instead of 2 records, suppose let's see I'm having 2 million records are there. Okay, tell me now what happens? Computation cost also will be there. Now same thing go for like. Tell me like syntax. What is the like syntax? Like syntax.
Only the structure is great.
Okay, so we can able to confirm. Syntax that what? So create table. So you need proper naming. So see, like, okay, like is the keyword, same thing. Now question is that what this will what it will have only structure will be there. Structure will be there. What about data? Data will not be populated. Now question is that what does it require computation power or not?
No.
Now why? Because so how to confirm? Go to 3 dots, view query profile. Where I should go? Go to query details. So see where it is empty. So in the sense like what happened now? So see like doesn't require any warehouse because there is no data. No go for no computation cost. No computation cost because there is no data. No computation cost. Now important thing now what happened? Tell me now cloning require computation power or not?
Yes.
Important question. Yes, sir. So see the same thing.
Yes.
Important point. Okay, let me go back here. Now what is syntax? So create table. Go for the table name. Okay. So Prav table. Important. Okay, see. Clone. Very, very important topic. Okay. What is the keyword? Clone old table. Okay, see old table. Okay, see the same thing. How to confirm? Go to 3 dots. Go to view query profile.
Query details.
Query details. See what happened? Tell me.
Yes.
Tell me, it's in. Okay, so no computation power. I'll try to explain details. So see, no compute cost. Okay, see, this is important thing. So see, when you want to take a backup, tell me which one is preferable as of now.
Clone is preferable.
So clone is preferable because no computation cost. Tell me what about storage? Tell me storage will be there here. See it as
Yes.
storage cost also will be there. Okay. What about here? What about like
no storage cost?
No, because no data, no storage cost. Okay, so see, this is important. No storage. What about clone?
No storage.
No storage cost. How can I say? So see, this is important. See the same thing. So see, I'll try to explain. So see the advantage of zero. So it's called see, cloning is also called as zero copy cloning. Tell me why called as zero copy cloning. Anybody why it's called as zero copy cloning?
No
Because,
cost is involved.
Okay, see, no storage cost plus no compute cost. Okay, see. So no storage, no computation. You can see by using query history, we can able to set. Now, how can you say it's a no computation cost? No, see, you need to understand. So see, let me go back here. See this paint, important, understand the functionality. This question will be used, this one question will be asked in interest as well as in real time also work on the cloning concept. Okay, see. Let me go back here. So see. So see this my table. So see. So see the same thing. Understand? I'll try to give detail. Don't worry, you can able to answer the questions. So this is my EMP table. This is EMP table. Okay. EMP table, it contains, okay, 100 records. Okay, 100 records. Occupying how much mean? 100 MB storage. Okay. Now what happened now? I'm going for C test. Now what happened? Tell me again. If I go for C test, what happened? Tell me. Again, how much storage cost? Control C. Okay. Control V. Totally how much storage cost? 300 MB storage cost. Now instead of this, what happened? If I go for page, now see. Control V. Now, so this is my main table. Now what happened? I am going for zero copy clone. See, zero copy clone. Okay, see, zero copy clone. Now what happened? Now here one advantage that what? See, okay. Okay, so there will be only one storage point. See here what happens. See here, separate storage is there. But when I go for zero copy cloning, what happened? All the three objects will be pointing to the single storage. Now in this cloned object, what it contains? Only the metadata information. One more time, I'll try to explain. 1 second, hold on. So see, 1 second, hold on. I'll try to see only the metadata information of micro partition. So see, one second, I'll try to explain. You can able to answer. So hold on. Now see, the actual data is sitting here, but what exactly this object contains? The micro partition information, the metadata information of micro partition. One more time, I hope you're not able to understand. See, 1 second. So see, here you need to understand 3 layers. What is the thing? The storage layer, computation layer, and the cloud service layer. Tell me, our data will be storing physically where? The storage layer. This information is holding by which guy? Holding by which guy? Tell me.
Cloud service metadata.
Cloud service, the metadata. So the micro parts information is holding by which guy? This metadata guy contains the micro parts information. Let me go back and show you the image. Okay, see, simple thing. Okay, go for cloning. Once you see definition, you can able to get the information. Now see what happened. Now our data is storing where? Physically in the storage layer. This information, the MP1, MP2 is storing by which guy? The metadata layer in the cloud service layer. When I go for CTest, what happened? Tell me. CTest. Again, separate storage will be there. Separate storage and separate computation cache. This is normal CTest concept. But when I go for cloning, see what happened? You see. See this image. Okay. What exactly we are trying to copy? Tell me. So see. So our data is storing physically in the storage layer. But what exactly we are copying? Copying on the metadata information of micro partition. When I go for this concept, see cloning, see it has nothing but what? The entire data we are trying to copy physically. But when I go for cloning, what happened? Tell me now. So it copies only the metadata information of micro partition, not the actual data. So here only what is copying? Only the metadata information of micro partition. See, if I go for this image now what exactly it's copying? Only the micro partition metadata information, not the physical data. But when I go for here, what happened? The metadata information and the physical data is copying. So that's why the storage cost is there. But here what happened? There is no storage cost info because it's a metadata operation. So not the physical operation. It's a metadata only. We are trying to copy the data. So one more time. In the zero copy cloning, what happened? We are copying only the metadata information of micro partitions, not the actual data. That's why what happened? Tell me now. We discussed what metadata operation doesn't require any computation cost as well as storage cost. So no compute cost plus no storage cost. So that's why it's called as zero copy clone. Without any additional storage and additional computation cost, we can take n number of copies of my table, my schema, my entire database. We can able to without any computation cost and store. That's what we call as zero copy clone. It's a metadata operation, not the physical data copying. Ask a question. Somebody is asking. Go ahead.
Yeah,
But
I have
you have
Go
main
ahead. Go ahead.
table
One more.
as well as clone tables, right?
Okay.
Okay, if there are any changes in the main table, it's
We'll
going
see.
to
We'll see.
reflect in the clone table.
We'll see that one. We'll see that. We'll not discuss. As of now, you understand the concept. We'll see that
Yeah.
question also. Okay. So see,
Yeah.
point is go ahead.
Uh,
Go ahead.
what is a micro partition?
Micropart is nothing but what? Okay, so it contains like our data is storing in small units. Okay, small units. Okay, in Snowflake, what happened? Okay, in Snowflake level. Okay, in Snowflake level, what happened? Okay, so see, our data is splitted into small units of storage. Okay, so this small units of storage is called as what? Micro partition. Okay, so partition. Okay, it contains what happened. Okay, like MBs of data it can able to accommodate. So instead of storing GBs of data, what happened? Storing into small partitions. Okay, see here what happened. So this is one partition. It contains one storage. It contains storage units like storage units. Contains it's a continuous unit of storage. Okay, storage purpose we can able to get it done. Okay, so same. Now the question is that what whenever I change any data. Okay, so tell me. Okay, so before going, tell me whenever I change any data in the main table, does it reflect in the clone table? Yes or no?
Yes.
It will reflect the.
No.
Okay, we'll see the same thing in detail.
No,
Okay,
just
so
copying.
okay, so see, let me help you the same thing. You can able to see when you complete all this question, you can able to answer this question. Okay, see now what happened. What is cloning? Tell me. What is cloning? What is cloning?
Copying the metadata of the base table.
Okay, so now it's a normal definition. It is used to take a backup. Okay, or replication or snapshot of. We can take a table, or we can take entire schema or entire database. We can able to take syntax is that what? So create. Tell me syntax. So create table name. Clone old table. Okay, same thing. Instead of table, I can go for schema level. Okay. Same thing, I can go for database level. So see the same function. So this is the same. Next question is that what? How to clone a table? This is fine. Why cloning is called as zero copy cloning? Tell me definition. Because okay, it's copying only.
Computing.
It's copying only
Only the metadata.
metadata
Of micro partition.
Information
of micro partition. Okay, and it contains no storage cost and no computation cost. Okay, this is fine. And next we discussed what? Okay, in which situation have you used clone your project? Tell me what's the use case, real-time use case.
for taking backup.
So see if I want to take any backup, okay, RN testing. See if I want to take any backup or testing purpose. Testing nothing but what we can't able to test on the live data. So should go for testing purpose. Okay, backup or testing the database object. Tell me, okay, see when you make any changes to the cloned object, does it get to the base table or not?
No.
So no.
No. It will
No.
not reflect on base.
It will not reflect. Let me go back and we can able to confirm. Okay. So go to Snowflake. So projects, okay, go to the same thing. Now what happened? We have cloned the same table. Okay, see, this is my main table. Okay, and this is my cloned table. Okay, so both are cloning. Okay, tell me. So select star from the same thing. Now what happened? Both contains 2 records or 3 records? 3 records. Now question is that what? Okay, now I change the data in my main table, insert into prav table values. So 4th record. Now tell me now this 4th record will come to here. It will available. What about here in the cloned object will be available? Yes or no?
No.
No, because so answer is Both are independent. So answer is that what when okay see when we make any changes to a cloned object or vice versa, what happened? So see there won't have no impact. Okay, so because both are independent of we should say this answer both are independent objects. The point is that what as of now two objects are sharing the same storage. Now, when we make any changes, what happened? This will not be reflected because both are independent to each other. So this is you should say. So both are independent. Now, same thing. Now, what happened? Now, question is that what a new record is the clone table. Suppose see I inserted new record in the cloned table. Okay, see the same thing. Understand the functionality. Okay, I have inserted what is the record. Tell me this record will be available in the clone table, in the main table. Tell me, I haven't said. Tell me, okay.
No.
No, it won't.
Both are independent.
Okay, see now what happens. See, 40th record is there in this thing. So it is not available in the main table because both are independent. Now, question is that what a new record in the clone table does it have storage or not?
No. Then clone table. Yes.
Yes, there will be a storage.
Yes.
Okay, see now what happened at this particular point of time, no storage. But what happened? I have inserted a new record. Now I inserted a new record where in the clone table. Now what happened? Now it will be inserted in the new micro partition. See what happened? See, a new record inserted. Does it have storage or not? Answer is yes, it will have storage. Where exactly stored in the new micro partition? See the same thing. So see, as of now, both are having the same storage. When I go for here, what happened? I have inserted a new record, new micro partition. So for this one, storage will be there. That's what the point. Okay, so this is the same. Now, question is that what can you perform DML operations clone tables or not?
Yes.
Yes.
Please tell me yes or no. Yes, no. Okay. How will impact
please.
original tables?
It doesn't affect on original table.
So see point because both are independent objects. It won't have any impact on the original tables or the clone tables. 1 second, mute yourself. So see point is that what okay, so this is fine. Now question is that what so see when you perform cloning, no computation cost. Okay, we can check from the query history. Okay, mute yourself. Okay. You see now what happened? No, we can get from the query history. We can able check. Now question is that what? Okay, now how can you prove it's having no storage cost? Okay, so theory wise we are saying it's a no storage cost, but question is that what? Okay, you to check the storage of a table. Now I want to make sure like it's having storage cost is 0. How can you check? Where we need to check? Tell me. Now theory is fine. Theory we are saying like it doesn't have storage cost. Now how can you prove practically? And that's what the question. Anyone? Come again?
In information schema, the byte column is there. So
Where
we can check.
exactly? So see, the information schema contains multiple views will be there. Out of this, what happened? We need to go for what? Go for what thing? See. So information schema dot table storage matrix. It contains the information. See what happened. So let me go back to Snowflake Snowsite UI. Okay, see. Okay, see. Select star from information schema dot. So see table. So if I want to get tables, go for tables information. If I want to get columns, we should go for what? Go for columns. Column. Same thing. If I want to get databases, go for databases. These are what? These are the views. Information schema dot tables, metadata information, columns, database. Same thing. I want to get storage information. How to get table storage matrix. So these are the way. Information schema dot table storage matrix. Okay, see. So see now what happened. Tell me now. I want to get what are the table names. Okay, see. I want to get list of tables starting with EMP details TT. How to get? Go for what? Go for where table name. Go for what? Go for like control with percentage. Tell me what exactly it will give. Tell me. It will give what?
Table name
Information
starting
only
with.
those table details.
So starting with EMP details.
EMP
Okay, it will
details.
give. So details. Okay, see the same functionality. Now, how many tables are there totally? 4 tables are there. See, 4 tables are there. Okay, see the same. Importantly, see the same functionality. So it's a concept. Everything is a concept in Snowflake. You see. Now what happened? Out of 4 tables, which tables are main table? Which tables are clone tables? Anyone? Any guess? Seeing this data.
First one is the main table.
First one is the main table. Okay. How? So see the data. We are
TT is the main table.
no. We are data. We should see the data completely. So see this data. Tell me which is the main table, which is the clone table. So see, this answer is there only. Okay. Remember, we are data, and we should see the data clearly. And tell me.
ID.
The clone group
Active
ID.
bytes.
The
Color zero.
clone group ID
All are
is
zero, na?
indicated.
See what happens. So see, here see this column ID clone group ID. See, both are same.
Same.
Okay, both are same. Okay, so both are same. What about clone? Both are same.
No.
Okay, forget where it's getting from where?
Main table.
From the main table. So see here what happened when ID clone group ID both are same. It's a main table. So these are main tables. But here what happened now? These are 2 are different objects. Nothing but it's a cloned object. Now question is that what? How can I find the main table? We should go for when ID clone group ID both are same. It's a main table. When both are different, say cloned object. Now it's getting cloned from what? C38922. This is the same thing. Now what happens? So this is fine. Let me show you one more use case, one more image, then you can able to confirm. Now see the same functionality. Let me take the screenshot. Okay. Out of 4 tables, tell me which tables are main tables. So see, so this is main table, main table, main table. What about this one? So both are different, say cloned object. Now it's getting cloned for the same thing. Now tell me now what happens having storage cost? Storage is there. Why it's getting storage? Because 3.5 is a normal, suppose normal records. Now what about like what's getting 0? Because
No data.
no data. What about CTAS? Because we are copying physically. That's why it's a storage will be there. Storage also see. Storage will be there. Now what happened? Now what about why it's 0? Because
there is no storage.
No storage. So see, how can you prove nothing but what? Information schema dot table storage matrix active bytes will be 0. But tell me now why we are having data. See, here data is there. You see, here data is there. See, when you see query this table, what happened? Data is available. But what happened? Tell me. So see, where is our table name? What's our table name? Okay, see employee details. So select star from table. Data is there. Data is there. Okay, see data is there.
Space up.
Select
Space up.
star.
Select.
Which one?
Select a space star.
Not ready. What?
Table schema.
Okay, we're in different
Table
schema. Okay, so we're in which database? So development DB, development schema. Okay. So go for database. So this is called as fully qualified. See, data is there. But what happened? Tell me now. It's saying 0. Why? Because tell me anybody reason, no sir. Why it's 0?
Because of less amount of data.
Not less amount of data. Okay, so data is data, no? Less data or more data, not. See, one record also record, no? With this Snowflake will be charging. Now see, point is that what? So there is some what latency is there. What is latency? Anybody? Nothing but so delay or sometime it will take. See what happened to populate the data in this table. It take around 1.5 hours to 2 hours. Okay, see, so we should wait for 2 hours to get the data will be populated. Tell me after 2 hours, data will be populated where? In which layer? In which one? First one, huh?
Storage layer.
Informative.
No, data will be there. Huh? Now data will be populated. No. See what happened. after 2 hours, okay, now I check this query. Now we'll get, suppose see it's occupying 100 bytes. Tell me 100 will come here or not? The main table?
Yes.
Yes.
Okay. What about clone?
No.
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 Zero.
What about like?
Yes.
Like
No.
like
No.
zero, no? No. What about C test?
Yes.
Yes.
It will be there. Okay. Why? Because, so see, we should wait for 2 hours because what happened, there is a latency concept. Let's see one more time. So see. So this is your task. Okay, see 1 second. Okay. Create the table with the following column constraints. Primary key, not null. Tell me now what happened if I go for C test, what happened? So see, tell me C test, data will be there, definition and no constraints and storage cost and the computation cost. What about like date definition, no data, constraints, no computation cost, no storage cost. What about clone? So definition, data, constraints, no storage cost and no computation cost. How can you prove after 2 hours? We can check the story, which is the column active bytes will be 0. Okay. When ID, clone group ID, both are same, it's a main table. When both are different, it's a cloned table. So this is the functionality. Got the point? Yes or no? So this is the way we can able to do one more time. So we try to conclude. So see with, okay, so 1 second, hold on. See, with the help of C test, we'll get what? Definition plus data plus what happened? Storage
constraints.
cost, no constraints. No constraints. Okay.
Storage
Constraints
cost.
plus storage plus computation cost. Okay, storage computation cost where you can check in the query history. We
Query
can check.
details.
Query history we can check. Okay. What about storage cost in the table? Table storage metrics. Okay. After how many hours? After 2 hours.
hours.
Latency is there. Okay. Same thing. Go for one more thing is that what? Go for like definition plus no data plus constraints are populated. So see what about storage? No storage cost, no computation cost. Same thing. Control go for clone. Clone what happened? Definition plus data will be populated. So constraints, no storage. Okay, now we can able to get it done. Okay, this is the concept. Whenever we perform any changes, okay, in the main table. Tell me trigger reflector. So answer is no, because both are independent to each other. Okay, so it's a metadata operation, not the physical data. So it doesn't require any computation, any storage cost. Okay, so this is the functionality. Okay, got the point. So see the same thing. So this is the way you can able and see the question. You can able to ask the question. See, tell me. Okay, how to find table is clone table or main table?
If
If
clone
the
ID and
clone ID is
Clone group
the
ID
ID is
not
not
equal.
same, then it is.
Where you should check? We should check the information schema that table
Schema.
storage matrix ID both when both are the same. It's a main table. It's a cloned table. Okay. 1 second. This one will see. Does cloning uses virtual warehouse?
no.
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 How can you prove? In the query history, we can able to check. Okay. Same thing. Does cloning occupy storage?
No.
No.
Because so how can you prove information schema that table storage matrix? What's the column name?
Active bytes.
Active bytes.
bytes. How long? After 2 hours, we
After
can
2
check.
hours.
Okay, now same thing. Now question is that what? So see, can we clone the clone table again?
Yes.
Okay, see, let me go back here. So see this employee table. Okay, go to which database? Development database. Okay, development schema. Okay, so create. Now what happened? So first create this table. So create a table. So see CL1 clone thing. Question is that what? Can we clone the clone table again? Yes or no? Is it Paul or not? Yes or no? It's Paul or not?
Yes, we can clone.
We can clone. Same thing. One more time. Tell me. Copy the same thing. Okay, see the same thing. Tell me it's possible or not.
Yes.
Okay, it's possible. Now question is that what? This object will be pointing to this object or this object or this object or this object. Tell me.
Main object.
Main, that is what? Main table. Okay. How to confirm? Select the star from information schema dot table storage matrix. Where? So see this one. So make this of reference, please.
Table name like
Okay, see. So this one make this of reference, please. Don't disturb us. Okay, table name like see percentage. Now tell me now what happened. Tell me for CL1, CL2, CL3 what contains which clone ID group ID? The main clone group ID. Okay, see. Put the semicolon. So see what happened. Okay, see all these objects are pointing to what? Pointing to
Same
which
thing.
one? So main table. Okay. What about storage cache? It will be 0, 0. This is the functionality. We can clone the clone table, but point to the main table only. Got the point? So this is the concept of zero copy cloning. Without any storage, we can take the backup. Okay. So tell me, I'm having 1 GB storage, 1 GB table is there. Now, which one I should prefer? You should prefer zero copy cloning because without any storage, I can take the backup of a table. Ask your question.